In this lesson, we're going to cover some material from Unit 2A. Specifically, we're going to look at, in algebra, what do we mean by these words terms, expressions, and equations, and how can we represent relationships algebraically? So if we can take a relationship that is expressed in words, how can we write it in terms of terms, expressions, and equations? So to start with, what is a term? Well, we'll just start with an example of a term. Something like 4x squared is a term. Okay? So is something like negative 3x squared y cubed, something like 2y, even something just like 10 is also a term. Okay? So a term is basically a set of things. It could be numbers, it could be letters, and they're connected together by multiplication. Okay, we don't write the multiplication signs in between here, but when we think about 4x squared, we really mean that we're taking a 4 and we're multiplying it by this x squared here. Okay, so the parts of a term, this number out in front, we call the coefficient. I think the learning guide uses the phrase numerical coefficient to emphasize the fact that it's a number. I'll usually just call it the coefficient. If we have one of these numbers that's kind of up above, what do we call that number up there? What would we call that in the little 2? It's called an exponent, yeah. So a lot of terms have exponents. Not every term has an exponent. Okay? And when we see a letter in here, like this x, I think the learning guide refers to it as a literal coefficient to emphasize that it's a number. I'm just going to call it a variable in here. Okay? So basically, a term is a collection of numbers, a collection of variables that are all sort of connected together by multiplication. Now, if I see something like 2 to the y, right there, I don't see an exponent on this. But if we don't see an exponent, we kind of assume that the exponent up there is going to be a 1. Okay, and that's going to become important later. We'll come back to that as we get further into Unit 2. Also, if we have a term like, let's say z squared, we don't see a numerical coefficient out in front of it, but we kind of assume that if we don't see a coefficient, that there's a coefficient of 1 out in front. So these sort of things are just kind of assumed. Okay. So that's a term. If all we're doing is multiplying these things together, we have a term. An expression is made by combining 2 or more terms using addition or subtraction. So if I take 2 of these terms that I have up above here, like 4x squared and 2y, and I add them together, I have an expression. Or if I take something like z squared minus 10 minus 3x squared y cubed, that's another expression. So once we combine them with addition or subtraction, they become expressions. And if we have an equation, we need at least 2 expressions and an equal sign somewhere inside this. So an equation always says that one expression is equal to another expression. So something like 4x squared equals 10 is an equation. Or something like z squared minus 10 equals 7y plus 2p squared. Once you put an equal sign somewhere between those expressions, you have an equation. So those are the 3 key terms here: equation, expression, and term. Now, where we're going to use these things are, we want to use algebra in order to solve problems. So often we are given a problem which is described in words, and we want to convert it into some sort of an algebraic expression. So usually we start by choosing our variable, or our letter here, to represent something. So in this case, we're just going to have our variable n represent some number. And then we want to come up with an algebraic expression that represents each of these things here that is described in words. So for instance, if n is our number and we want to represent the number being increased by 5, this word here, increased, is describing a mathematical operation. If we're increasing this thing by 5, what mathematical operation are we doing here? We're doing addition. So we would have n plus 5. Okay. Next one here, we've got 2 less than the number. Okay. Less, again, that keyword there is describing a mathematical operation. We're doing subtraction. So we would have something like n minus 2. Okay. A number 7 times larger, again, this keyword times here is describing a mathematical operation. What operation are we doing if we've got that word times in there? We're doing multiplication. So we would do 7 times n. And if we've got something like 7 times n, we can make a single term out of this. Okay? Just like on the previous slide when we were writing those terms, we didn't write that little multiplication sign in between. We can write that just as 7n. Okay? And we just sort of assume that when we see those things next to each other in a term, that we're multiplying the two of them together. Next one's a bit tricky. What about a third of our number here? This keyword, a third. What operation are we doing if we're taking a third of something? By how much are we dividing by? We're dividing by 3. So we could write this as n divided by 3. Or we could write this as n over 3. Or we could write it as 1/3 n. Okay? All of these are equivalent. Okay? And sometimes we have sort of 2 operations that are being described in one statement here. We have 5 less than triple our number. So if we're tripling our number, we are multiplying. So we've got 3 times our number. And if we're doing 5 less than that, the operation that we have to do is subtraction. So we're going to subtract 5.